And then our next speaker is going to be Emyr James. He's going to talk about his work here now that he figured it all out.
Hi, I'm Emyr James, Head of Scientific IT at the CRG. I'm going to give a little bit of an overview of CRG itself, our team, our journey so far, the adventure in iRODS at the moment, how we're doing that, and then maybe an idea about how we might enhance the metadata. Okay, so about CRG, the Center for Genomic Regulation, Barcelona. The Institute does mainly basic fundamental research. So we're interested in how biology works at the fundamental level rather than, applications. So there are applications being developed, but it's more focused on the lower side of biology. We're an international institute. We're one of the few in Spain who have got the Severo Ochoa Center of Excellence status. We have around 35 research groups split into 4 programs: computational biology and health genomics, quantitative cell biology, genome biology, and systems and synthetic biology. Those groups are served by 7 core technology units. There's a 3D virtual tour that you can see on that link there if you want to go there. The units are the genomics unit, bioinformatics, flow cytometry, proteomics, microscopy, protein technologies, and tissue engineering. So the focus of this talk is mainly around working with the core technologies where data is generated, and then how do we get that into the users and to the research groups. So that's CRG. Now the team, the scientific IT team, we run all of the HPC, the storage, and the scientific data infrastructure for CRG. The methodology we try to do in the team is infrastructure as code. Everything needs to be reproducible, version controlled. We have an internal Git lab. That's our kind of way of doing things. We also really like to build things in-house. We've got our own portal that we wrote in Django. We have a system for mining data, all of the metadata for all of the files, and we use ClickHouse database for data warehousing for that. There's 8 of us all together with specialities across storage systems, virtualization platforms, DevOps. We've got a tape archive system running on Beros with a layer above that we wrote in-house. We also have web development skills in the team, generic software development, and HPC compute specialty. So storage and why iRODS is a good fit for us. So we already have plenty of storage. We've got an Isilon NAS system, Lustre Scratch, a lot of tape, LTO8 and LTO9 media, but storage doesn't equal data management. So, the questions that we're interested in, where does the data live? Which storage technology is appropriate for what data? Who can see the data? How is the data described? And how do we keep provenance on the data? So some of the data that we deal with is medical patient data. So, we have to protect that. And in general, we use Unix groups for managing the data. And that's proving to be a bit of a problem. We're creating lots and lots of virtual groups for different collaborations, and it just becomes a nightmare. So this is, I think, where iRODS is really going to give us a lot of value. We've got a catalog, we've got metadata handling and access control in the iRODS layer. iRODS also has storage kind of technologies within it, replication and so on. But for the moment, we have that in hand, so we're not going to do that at the iRODS level yet, but we might do that in the future. So my initial exposure to iRODS was at the Wellcome Sanger Institute, as Terrell mentioned. So it's basically the bedrock of the storage system at the Sanger. They have a very large sequence of farms that generate the data, and it's immediately ingested into iRODS along with all the metadata. And then the users pull that down onto their Lustre Fast Scratch for processing. and moving forward to collaborators and so on. So after the Sanger, I moved to the CRG, and CRG is part of the EU Life Consortium, which is around 14 institutes across Europe that collaborate to lobby the EU Commission and so on to try to forward biological science. We have annual meetings, and in those meetings, there is a lot of interest in iRODS. So the Netherlands Cancer Institute, for instance, are really pushing forward on that with the help of Surf Sara in the Netherlands. We've spoken to people at VIB there as well. So, you know, if you decide to go for iRODS, the community is very helpful, and everybody can learn from each other, and everybody's happy to, you know, work with people and, you know, give them advice. So we started to look into it, but really we kind of got stuck. We were in analysis paralysis, and I think maybe this, you know, is kind of ringing bells for a lot of you. You know, iRODS is a complex system. There's lots of things you can do. So you start to look at it and you think, oh, how can I use all of these features? You know, and you kind of go through trying to design the best way to do your data, and you basically never get anywhere because, you know, you're just in that state. Well, that was true for us. So, you know, after, we decided to hire a research data management lead. So Rolf in the team, he sat over there. So he joined, and also we had 2 more people join in Jan 2025, which enhanced the team and gave us a bit of leeway then to push more on projects rather than supporting users. And because we now had a person whose job was research data management, it kind of focuses the whole institute that this is a thing. So, you know, I think having the organization ready to go for proper research data management is just as important as having the technical skills. Because we got stuck in this sort of analysis paralysis, you know, with Rolf coming in, we decided to change tack. And we kind of worked with the core technologies then to come up with a kind of mission. And what they're trying to do is this concept of multi-omics, where it's around single cells. So they have lots of cells, and they can sequence individual cells and, you know, see different expression of genes within cells. And as well as the genomics, they can do microscopy of the cells. So they've got localization as well. And then the bioinformatics take all of that data together and analyze it. So because with all of the institutes are kind of working on a kind of across curricular platform, the data needs to flow between them. So we need to keep the provenance and metadata going at every step. So one thing that we do at CRG, all of the core technologies use a system called Agendo, which came from the Gulbenkian in Portugal. So this is used for users to request work from the core technology. So this is about booking at the moment, but Agendo are very keen to push the concept of having ontologies and metadata right on the request stage. Once a request comes in, we have an in-house LIMS system which manages the experimental side of things. The sequences and so on. Then, you know, once the data has come out of the sequences, it's put into iSalon, and the bioinformatics team can do quality control and downstream analysis. So the mission, you know, this was kind of the real thing. There was the analysis paralysis. We were kind of working on our own and thinking of it as a technical problem. I think unless you have, you know, the science side working with you as a collaboration, you know, it's not really going anywhere. You need to have both sides pushing and helping each other to really push forward with progress. So, you know, we kind of totally reframed then into this MVP paradigm, minimal viable product. So rather than trying to analyze, you know, put together a big plan, we just try to build the smallest thing that could possibly work, and then play with it, learn about it, and then iterate and let the system grow with us and as our knowledge expands. So we just set up a simple system, an iCat in a virtual machine and a single resource in a virtual machine mounting an isolon folder. So we didn't need to think about replication and offsite and things like that. Isolon handles all of that. One thing we had to get right was authentication, which did hold us up for a bit. But we got to the stage pretty quickly where a user can input and I get a file to the system that we set up. And that was the foundation. So within the LIMS system now, we've got a little menu here which has iRODS in it. So they can select that within the LIMS, the people that operate the sequencers in the genomics lab. And at that point, they can set metadata. So there's metadata here that comes in automatically. They can add extra if they want. Also, it's setting the access controls. So this is for users in the bioinformatics unit. And then they press a button and the metadata, the data itself, and all of the access controls are all done through the Python backend linked into the Django LIMS system. So we've got that working as a kind of little standard operating procedure. The bioinformatics team, we're closing the loop then by getting the data out of the iROD system, staging it to Lustre, doing more analysis, and then putting that back into iRODS. So those kinds of things can be done with the rules engine, but we're not putting in all of the features immediately, right? We're just one at a time, learning more and pushing forward. And then once we've got further with that, we're going to be working with microscopy, who have got an Emyr system, which again generates a lot of metadata so that we can look at the microscopy side. So now we've got a core team of 6 across bioinformatics, genomics, and SIT, and we meet weekly. So it's kind of like an agile scrum in spirit, but weekly rather than daily. So on the metadata side, this has been raised in the community. You've got the AVUs, but we have the A and the V, but usually the U is empty. Okay, so I think this is quite common that people do key value pairs, and the units thing is unused a lot of the time. So the AVU is a triple. So when I see triple, I think RDF triples. And other people I've seen, they have ideas about how they want to use this metadata in a different way. So the idea that I would take forward is, we could think of the AVUs as the semantic web triples. So, you have subject, predicate, object. So the sky is the subject, has color, the predicate, the object blue. So you can map this onto the AVU paradigm that you have, the attribute. So in this case, the subject is the data object. And then the predicate would be the attribute. The value can come from an ontology, and then you can use the unit to point to the schema, basically, of the ontology. So that's a way that we're thinking of using the system that's within iRODS to maybe look at this more semantic way of doing metadata. So with this sort of system, then we can possibly look at there's a system called Debezium that looks at the logs of the Postgres database, and we can farm that out to different backends. So for instance, a ClickHouse backend for doing analytics, a Solr or OpenSearch for faceted search. And then if we can get this AVU semantic thing going, maybe TripleStorm to do Sparkle and reasoning around the metadata using the semantic web kind of methodologies. How that would fit within iRODS, there are obviously plugins that we could leverage, but the Debezium would then allow you to handle the case where somebody doesn't use the iRODS tools direct and things change in the database. One idea that I had was that people are using the AVUs in different ways. For instance, there was a method that they were encapsulating a tree hierarchy for metadata. So I was wondering whether we could have a metadata type table, which, out of the box is just populated with the AVU way of doing it. And you could add your own types, like the hierarchical one or the semantic one. And then when you put data into metadata into the database, you can link it to the type ID. So you can have different ways of working with the data and be able to query and filter out different types of metadata to give a bit more flexibility. So that's a bit of a flavor of where we're thinking of going with the metadata side. But the bigger picture, we're working with the core technologies first. And when we've got that working smoothly, we can then, bring the research groups on board. Obviously, then we're going to need to have nice user-friendly interfaces. So we're looking at Yoda and Mango for that. And obviously then, as Nuno mentioned, the whole idea is to get to satisfy the fair data principles, which iRODS obviously has. It's there. That is a great solution for it. So for the Institute itself, these are the acknowledgements for the Institute, the people that help us do what we do. And thanks. So maybe we can see some of you on Thursday back at CRG for the troubleshooting. And if you can, maybe take a stroll down on the beach. Thanks.
Do we have any questions? Oh, we have one here.
Hello.
Hi.
Thank you for the presentation. I would like you to give us just a very brief idea of what data we are working with here, because there have been many decisions of architecture, technologies, tools, and let's say the pipeline where the data is gonna go through. But I would like to know a bit more about what data, what are the main characteristics of this data.
Okay, so by far the format that uses up most space on our system is a format called FASTQ, which is raw sequencing data. So in sequencing, you get a big genome, and it's like you blast it with a shotgun and turn it into tiny fragments, and those fragments are reads. And the idea is that it's like a big jigsaw puzzle, that you try to line up these parts to reconstruct the actual sequence. So, the FASTQ is basically a big long list of reads that are maybe 100 characters long, with some other information about the quality of the reads and the bases. And then they take that and reconstruct the genome from it. So that's the biggest one. In microscopy now, the technology in imaging is advancing rapidly. And a single experiment there can generate up to 10 terabytes of raw data, which does get processed down. But we do have to keep all of the raw data pretty much for 10 years at least. So, that is going to explode in the next few years, I think. Is that the sort of answer you were looking for?
Yeah, thanks, because I was looking into also the volume and, the typical stuff that you look into big data, volume, velocity.
Okay, so in terms of volume, we have on the Isilon system, we have around 4 petabytes. We've got 2 petabytes on tape, and there's about half a petabyte in the scratch systems. But we're probably growing now about a petabyte a year, and that's just going to increase in the next few years.
All right, thank you.
All right, do we have maybe one more question? One right here.
Is that 4 petabytes replicated or just like the raw data?
Sorry, I didn't hear that.
Yeah, the 4 petabytes, is it with replication or?
So we have a 2 petabyte. So what we normally do, we buy a system every 5 years. And when we get a new system, we take the old system off site, take some of the nodes out to keep us spares, So obviously the new system is much bigger than the old system. So on the new system, we split into sort of two folders. One that is for the primary data and for the scripts and so on, and that is replicated. But then the other part of it is for derived data, which doesn't need to be replicated if you've got the primary data.
All right, thank you.
All right. One more question.
Hello. You talked about providing a lot of data among different institutes. So there would be a discussion on how to share them. What are the discussions? And if at all you're thinking about providing the data and the compute together and in one whole package?
So we will probably, be working with the Caixa Foundation here. I think they have a great vision, and it would be great to work together on that. In terms of CRG, the core technologies do have a lot of external customers that we collaborate with, and our solution for delivering the data to them is to use the Globus system. So we do have the LIMS being able to work to Agendo and the LIMS and Globus. We've kind of all got it as a kind of loop, and that works quite well. We are trying to do sit as a service so that we generate the data for externals. We have a contract to keep the data for 6 months. So we may as well say, well, the data is here. We've got a bit of spare compute capacity. Instead of taking it off and doing your own compute, just use ours in the evenings and so on. So we are looking at maybe offering that.
All right. Thank you.